Considering that cos theta is the adjacent divided by hypotenuse, which for this triangle would be A divided by R, and you can rearrange by multiplying both sides by R and then substituting the A in A for R cos theta, and then considering that sine theta is opposite divided by hypotenuse, which is B divided by R, multiplying both sides by R would give you R sine theta equals B, and you could substitute that for B, then you're left with this equation, which you can factorize out the R to leave you with this, if I were to put a lovely little bracket around there. Now, in these circumstances, you can then say, well, z squared would be this whole situation squared. Z squared, therefore, is r squared cos theta plus I sine theta squared, because r would end up squared, and you can take that out, and we've taken that out from before. Finally then, instead of writing cos theta plus I sine theta squared, why don't we expand it? You can also use Pascal's triangle to expand it, but I thought I'd do it nice and step by step. That is to say, what I'm doing is I'm going to take the cos theta multiplied by the cos theta, equal cos squared theta, I sine theta cos theta, I cos theta sine theta, and then these would multiply to make I squared sine theta, or sine squared theta. This expansion is something that we can simplify down quite nicely, but I'm going to skip the step of turning them all into squared theta, squared theta. What's most important is this I squared, because we tend to get caught up around the squareds and cubes and so on. This I squared here is the equivalent of minus 1. So what we're going to do is we can then say this is minus sine squared, this is plus cos squared, and I'm going to put them together in this circumstance here. This, therefore, is that simplified. The imaginary parts I'm going to put together, sine theta cos theta is of course the same as cos theta sine theta. So there are two of them, and I've factorized out the imaginary part as described here. Notice that cos squared theta minus sine squared theta is cos 2 theta, and that comes from, like we described before, our double angle formula. So we are utilizing it from the very beginning in our discussion of what it means to be, or what is the simplified version of z squared here. This is what we're doing. We're like, well, can we simplify z squared so it can aid us in concepts later to, as described before, aid in solving this problem once we have a good understanding of complex numbers. So, additionally, this sine theta cos theta, that is also a double angle formula. That could, or you could utilize a double angle formula to simplify this down considerably. It's sine 2 theta, and I would suggest, if you're not comfortable with that, have a go of considering that if both of these were 2 theta, if those of these are theta, so theta plus theta with 2 theta, then this would be sine theta cos theta plus sine theta cos theta, and so this is exactly what that is, and I can therefore convert it quite comfortably into our situation of sine 2 theta here. So that is sine 2 theta, and as described, this is cos 2 theta for similar reasons. And this is a lot more elegant relative to the indices here, or the expanded version that we've gone through, and hence we can conclude that z squared can be equal to r squared cos 2 theta plus I sine 2 theta.